Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos, we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sample in statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour. So I've broken that up into multiple videos, and in each of those videos, you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. Now, once you have the sample of laptops that you need to go ahead and test to get the data, we can go ahead and create an experiment. So for this experiment, let's think of it as you're getting the laptop and you're charging the battery for that laptop, and then you power on the laptop, note down the start time, and then wait until the battery drains or runs out completely, zero charge, and then you measure look at the stop time. So battery life is in minutes or hours based on the stop time minus start time. And let's say you've decided, you and your team has decided to measure, let's say, a sample of 1,000 laptops from those millions. So here is one example of the points noted. Laptop number 1, start time was 11:10 a.m. Stop time was 11:30 a.m. and thus the battery life of that laptop was 20 minutes. Okay. Now let's move in one by one into each of these points that were shown in the first slide. So histogram, how do we build a histogram and look at the distribution? So let's say you've measured the battery life of the first laptop, and the battery life was less than 10 minutes, as you can see shown here by a blue dot. What we see here is binning process. Okay, the x-axis has different bins. The first bin would have counts for the laptops that have a battery life of less than 10. The second bin has 10 to 19, and so on and so forth. So last bin has the counts for laptops that have battery life greater than 60 minutes. So the first laptop had a battery life of less than 10 minutes, and so we put a dot there. Next laptop number 2, had a battery life between 20 and 29 minutes, so we have that one there. Next, again the same, and so on. We go through this process, and in each step we pile the dots on top of each other, so that we are kind of building a histogram there in this case. And so what this tells us, by now we have measured 1, 2, 3, 4, 5 and 6 laptops, and out of these 6 laptops, one laptop had the battery life less than 10 minutes, one laptop had battery life between 10 and 19 minutes. There were 2 laptops that had battery life between 20 and 29 minutes and 30 and 39 minutes. Okay, so as we find more and more data points, we can keep adding them to these bins, and finally you've measured all the 1,000 laptops, and these are not 1,000 data points, but assume that these are 1,000 data points, and you have finally created this complete binning process and a histogram. So to see the histogram as we saw it when we plotted them in previous videos, what you could think of it as drawing rectangles around these. So if you draw rectangles around each of these bins, dots around these bins, then fill them with a color, and now you have a histogram that we have previously seen when we use matplotlib to plot the data. And on the y-axis, what we have is counts is just how many of those laptops we had battery life in these particular each of these bins. Okay, so counts is just count number of laptops in this case. And this particular histogram for a sample can then be used to approximately or closely show the distribution of the entire population population. In this case, we have around 300 million laptops. So we could say that this histogram on the left in some way represents the distribution for the entire population of all other laptops battery life. Okay, then the blue line that we see on top of these bars and the y-axis is now changed to PDF values. That's converting these raw counts to probability density functions. We won't go into the details of that in this video, but think of it as a chance for a particular laptop to fall in each of these bins. So something like a probability. So what is the chance that, and the chance would be here on the y-axis, which would be in a decimal place, or it could be greater than 1. The idea there is that the total area under the curve is 1. Okay, that's how it is. Next, let's look at what are the types of distribution. So here we are only going to look at one distribution, which is a normal distribution, also called as Gaussian distribution. But Gaussian distribution can be mathematically thought of as differently, but here we'll use them as the same thing. And what it is inverse. It's like a bell-shaped curve, as we see here on the right hand side. And when we go ahead and plot these data in Python, I've already gone in Python and plotted random normal distribution of 1000 data points. And let's assume that here we see that the mean is 35 minutes of battery life, and that's more or less in the center. That's not always the case, but in normal distribution it's towards the center. And the smallest battery life was around 5 minutes, largest was around 65 minutes. And we have a nice looking distribution here. So on top of this distribution, now we can draw the probability density function and on the left hand side you can see the decimals for the values. And on top of this plot you can also see a box plot which is plotted horizontally, and there is a reason for that. And the reason is here this particular line, which is Q1, as you already know, or if you do not know, that's fine, represents the first quartile, which is to say that 25% of the data lies below that line. Okay, so lies below that line, which is shown here by the blue shaded area, and there's some more here as well. So this is around 24.2, and there's some more here. Median is the second quartile, or the 50% of the data lies below that particular line. And here the red line on the curve, that's mean, that's for the mean of 35. And as you can see, median is slightly to the left of that, and that is perfectly okay. So the 50% of the data is slightly to the left of the mean. Then Q3 is the third quartile, or 75% of the data lies below that line. And So only 25 lies above it, and therefore we have around 24.7 here, and there's some area down here as well. And in each of these sides there are two vertical lines, those are called caps, and that the cap on the left hand side represents the minimum and the cap on the right hand side represents the maximum, and the green dots that are shown there, those represent outliers. But depending on the project you are working on, those could be considered as outliers, or those may not be considered as outlier. Okay, but this is kind of the standard format in which whenever you see a distribution or a histogram like this, you probably also want to start thinking about box plot. And if you think about a box plot, you should also kind of imagine this particular distribution that you see here down below. That was it for this video. I hope to see you in the next video where we continue discussing statistics. Please like, share and subscribe. Thank you.